Why?
So we're going to graph this 3 cosine of theta. If you don't know, this is a circle. And the reason why it's a circle is, notice if I get another r here, that's r squared equals 3r cosine of theta. And once again, what's r cosine of theta? X, right? So this becomes x squared plus y squared equals 3x, and I can just subtract it over. It does make it a circle, with just our center being at 3/2, comma 0. Everybody with me?
So x, whatever it is, so it's basically
Okay, so all we're going to do, guys, is plug these thetas in for theta and get our r value. I'm going to do it kind of quick because it's really not too hard. I might ask you guys to, you are more than welcome to move. I'm sorry I'm in such a big body.
It's good. It's good.
I know. I worked hard. 3 cosine of 0. Cosine of 0 is 1. 1 times 3 is 3. I'm going to graph that point really quick just so you guys can see. Notice I'm at 0 radians. 1, 2, 3. See where that point's at? Yeah. Okay. Pi 6. The cosine of pi 6 is root 3 over 2. 3 times root 3 over 2. Somebody help me out with that, please. 3 times root 3 over 2. I have no idea. I know it's roughly
root
something.
3.
Oh, you want that?
Not just root 3. 3 times root 3 over 2.
3.59.
That was 2.6, roughly,
yeah.
right?
I thought it was 3.
Okay. So here's pi 6. So 2.6 is roughly right there. Does everybody see that? Remember, we graphed the radius on where it would be roughly on the angle, correct? When we do polars.
Oh.
Is everybody with me on that? Remembering how to graph polars? A couple times ago, we do our radius on the radius at the angle. Okay, so pi thirds, cosine of pi thirds is a half. 3 times a half is 3/2, so 1.5. So roughly right there. You can, but it's just up here. It would be 3 times root 2 over 2. What's that? Machine it. Working on the calves. 2.12, so that's roughly like right there. Kind of makes sense. Still. Oops, don't have that one. Alright. Then we're going to go pi halves. Cosine of pi halves is 0. 0 times 3 is 0. So right here, you're back down there. 2 pi thirds. Cosine of 2 pi thirds. What is 2 pi thirds? That's a half. Negative a half. Negative half times 3 is negative 3/2. Okay, now we got a slight situation here, ladies and gentlemen. When you have a negative radius, remember you're going to go to the angle. Here's 2 pi thirds. Here's 1.5. But remember, because it's negative, what do? I push through to the other side, correct? Everybody see that? Do you remember that? Okay, coming down here at 5 pi 6, that would be 3 times negative root 3 over 2, which is just going to be negative 2.6. So we're coming over here, negative 2.6, push through, roughly right there. And I can do pi, 3 cosine of pi. Cosine of pi is negative 1. Negative 1 times 3 is negative 3. Notice negative 3 is here on pi, but remember with a negative radius, we push through and we're back here. So basically I have my whole graph. Has everybody got that? Now, once again, what do we kind of have an understanding this should be? A circle, so just kind of making a circle. There it is. Make sense? Just a lot of plotting points, a little bit different than you've ever done before. We just had a connection of points, right? Collection of them. Let's go ahead to our calculator, show you the exact same thing. So r equaled 3 cosine of theta, isn't that what it said?
Yeah.
Alright, so 3 cosine theta.
So how do you?
Theta is just the x button. Because we're in a different mode. See how it says theta is the third number? Because we went over the polar, which was the third thing over in our form. Okay, everybody, you're going to hit zoom, trig. Because we've been putting trig information in, haven't we? So 7. And there's your circle.
So, when it just the standard window?
It still does it, it's just very small. Huh? It looks like ellipse just because of it is a circle. I can prove it to you if you want.
No, I believe you.
Yeah. Would you like me to? Alright. I'm gonna do it on the sideboard over here though. So I'd have x squared plus y squared equals 3x. We did that, right? Subtract it over. Now I need to complete the square. You guys haven't, you guys did circles last year, so I'm kind of going fast. Cut this guy in half. We did complete the square earlier this year. You cut him in half, that's 3 halves, then you square it, that's 9/4. So therefore, because I added 9/4 to this side, I gotta add 9/4 to this side. And then plus y squared. So this becomes x minus 3 halves squared plus y squared equals 9/4. In a circle, this would be your center is 3 halves comma 0 with your radius being 3 halves. So, therefore, this is 1.5, so kind of, does that look like our center point?
Yeah.
Notice we are going up 1.5 or 3 halves roughly. That looks like 1.5, doesn't it? What's 1.5 plus 1.5? 3. 0. That looks like roughly 1.5. Okay? Everybody with me on that? All right. Like I said, though, you're going to go ahead and graph these. As long as you know how to put some points in on cool, but you're also going to be graphing a lot of these with your calculator. That's what a lot of your assignment's going to be. For my case, I'll show you when the math, actually I want to see math done, but that's where I come in. Yes, sir?
I'm still confused in how we plotted on the y-axis. I get like the r.
Well, there's no y-axis on a polar. There's r's and thetas. It's just a different whole plane. It's just different a little bit. It's just a whole different plane. You're gonna see stuff that you've never seen before. That's something you've never seen before, right? But if you kind of think about this as x and y, even though this is 2 on my radius, but if I come straight over, it's not 2 on my xy scale, is it? No. But all these are just the angles. You need to put your radius on that angle measurement. Once again, you can convert back and forth as these points to put them on an xy coordinate so you can see it. Be the same idea. No? Where am I losing you?
I don't know. My brain thinks in x.
Well, you got to get out of that, bro, because it's going to change you. You got to be able to adapt. It is an x and y. But think about it just like I did there, though, because this is 1.5 x, 0 for y. Notice roughly right there, that was the high point, right? If I pull him over, that's roughly 1.5. I mean, I'm not exactly perfect because it's not to scale, correct?
Yeah.
So look, that's up a half, so that's 1.5 over 1.5. That should make sense if my radius is 1.5. It's there, you just got to think of the radius as well. Okay? All right. So we're going to scroll down. Oops, sorry, I forget I can't do that. All right, so just to let you know, though, if you can also see, you see how this circle is symmetrical about what you think as the x-axis? It's symmetrical, right? Things with cosine are symmetrical about the x-axis, or it's called something different. It's called the polar axis. We'll get to that down here in just a second. Sine is always going to be symmetrical about this line, which looks like the y-axis, but we're not in xy axis, are we? It's called the line of pi halves. halves, because this is pi halves in a radian, right? Does everybody see what I'm saying by that? So you'd be reflecting about the line pi halves. Yes, no? Okay. All right. So that's what this is talking about. Cosine's always going to be symmetrical about the polar axis. Sine's going to be symmetrical about the line of pi halves. Okay, and that should make sense because sine is y values, right? Symmetrical with y values. Cosine is x values. If you think about it in that way as well, correct? Okay. All right. So we have some different types of symmetry. Okay, and this is what the three types are. You have symmetry about pi halves, the line pi half. Once again, that's this. So if you have r theta, if your symmetry about line is pi half, okay, just kind of tell me, if I did an xy coordinate to be okay with Stephen for right now, if I'm up up 4 over 3, what would be the point symmetrical to this point over the y-axis? -3, 4, right? But if you think about this in polar doesn't have x's and y's. It has angles and radius. Wouldn't this be on the same radius? So does your r switch? No, and that's what this says right here. You're going from r theta to r, I'll show you this, r comma pi minus theta. And let me explain this. This is talking about reference angle. Because once again, if I have that point right here, what's this angle? Well, it's going to be some kind of angle, isn't it? We'll just call it 20 for right now, even though it's not 20. But you guys get the idea. He's such a nice guy. Anyway, this has the same angle to get to that point, doesn't it? So technically, though, what's that angle? Isn't it pi cut back that angle? And so that's why we go pi cut back that angle. That shows you the symmetry. Well, what else could I do? I could have actually went this direction, your theta. But remember, if I'm down this angle, your r would have to be negative to push me back over into here, huh? Does that make sense? So you could also go, instead of that, to negative r theta. Those are the two options to show symmetry. Okay? Let me give you, for instance, an example of that. Oh, that's nice. You don't want that in there? That's okay, I'm all the way back here. Ooh, we're getting close. We'll get that, that's important. Alright, here we go. We're going to test for symmetry. Okay? So R, does that say R equals 3 plus 2 cosine of theta? If they're symmetrical, meaning you plug that stuff in, you should get the exact same equation. Okay? So let's try both. So remember, let's try, because it says cosine, remember how we kind of talked about cosine really quick? Cosine is symmetrical about this polar axis. Okay? So I'm going to start here. And notice, if you have r theta, wouldn't it be r negative theta because it's the same angle, but he's just going backwards? So your radius is the same, but your angle is just going backwards, right? Or you can call yourself negative r. So you're up here. See how this line and this line are on the same axis? So this is theta. So obviously going here would be pi minus theta. But that would just have to be negative r to get you over to this side, correct? So here's this one. It's r comma theta. To show symmetry, you're either going to do r comma negative theta, or you're going to do negative r comma pi minus theta. So those are your two ways. So we're going to show that right here a little bit. So we're going to try r comma negative theta, okay? Does that make sense? So our R stays the same, so I don't change him. So it would be R equals 3 plus 2 cosine of what? I'm going to change theta with negative theta. Now, if you'll recall, when we first started doing trig, this was one of the identities that we had. Remember, because cosine was what we called an even function, it ate up our negatives, right? And that should make sense because the fact of the matter, here's a graph, here's 30 degrees, and a graph that was negative, or not a value at 30, or negative 30 degrees are the exact same. A value at 150 is the same thing as negative 150 because remember, cosine is both positive on this side, cosine is both negative on this side, so they're the exact same spots, aren't they? So it absorbs that negative. You guys remember that rule? There's some trig identity. So this one just absorbs it. So notice R equals 3 plus 2 cosine of theta proves that it is symmetrical about the polar axis. Yes, sir?
Which one did you replace?
I replaced R, originally R with R, and theta with negative theta. That a little bit more distinct.
Okay.
Or I could change negative R with pi and theta with pi minus theta. But that one requires, how many of you guys remember your sum and difference formulas? So that's why I'm not going to probably do that one for you. Because that's on there. Okay? Yes, ma'am.
So whenever there's a negative in cosine,
It just absorbs it. You guys remember what sine does if he's a negative in there? It comes on the outside. That's kind of a good thing because a center makes you negative. That's kind of a good way to think about it, to be honest. Okay? So where cosine absorbs the negative, sine takes it on. Is everybody okay with that? And then they have 3 different types once again. They have it about the line equals pi halves. Polar axis and the pole is about the origin if we were in XY. The pole is like 0, 0. So that means you'd be reflecting straight over it. Huh? Does that make sense to everybody? Like I said, sorry about the worst lesson that you probably have this year. I'm trying my best, but at the same time, I'm asking you to do a lot of just solving. Like something like this isn't too mathematically hard, was it? And a lot of the graphs are going to come from your calculator, like these guys. They're called limicons or limicons. I don't know how we say it. I can't remember. But see how they're cool little dimply circles? That's what polars can do. Yes? Oh my hell. I'm just teasing. By the way, this one shows that to show symmetry, you have r theta, and you're going to negative r theta, or r comma pi plus theta. Okay, are you good now? That just looks all dirty. Am I good? All right, go ahead.
So, like, looking at the whole symmetry thing,
Uh-huh.
are we gonna, like, have to prove that it's symmetrical and,
Not on the graph.
and, but with the equation by our thing, with the necessary?
It might ask you to do that.
Will we have to make any symmetrical?
All it's asking is say, is this, well, what type of symmetry would this have? So you can already kind of see it through a picture. Like, look at this one. Notice your little dimples right there, right? How is this symmetrical? Is it symmetrical about this line, pi half line? Is it symmetrical about the polar axis?
Yeah.
So then you would just, okay, this equation, we're gonna, you know what I mean? This one's technically a cosine one. How do I know it's cosine? Because it's about the axis. What this one would look like is either, oops, sorry, I'm not just kind of looking like that, or like that, because it's symmetrical about the line. You guys get me what I'm saying by that? No. As long as you kind of know what that shape is, that's what's important. Because once again, I'm going to let you calculate. But I'm going to show you how to graph them just in case though. So pi halves, negative pi halves. What's the sign of negative pi halves? Negative 1. So that would be 3, negative 2 times negative 1, which is 3 plus, it is. So 3 plus 2 would be 5. So I come all the way out over to 5. 1, 2, 3, 4, 5. I'm going to move them over here right now. Okay. Then I plug in negative pi thirds. Sign of negative pi thirds is negative root 3 over 2. So this becomes 3 plus root 3. Can somebody help me with 3 plus root 3? I think it's 4.86. All I did was plug him in. Because it's negative root 3 over 2 and the 2's cancel. 4.7. Negative pi 6, the sign of negative pi 6 is negative a half. So that'd be 3 plus 1, which is 4. We do 0, sign of 0 is 0, so 3 minus 0 is 0. Excuse me, 3. Apologize. Pi 6, sign of pi 6 is a half. 2 times a half is 1. 3 minus 1 is 2. Pi thirds is root 3 over 2. 2 times that would be root 3, so that's 3 minus root 3. Somebody help me with that, please. 3 minus root 3. And then I got pi halves. Sign of pi halves is 1. 3 minus 2 would be 1. Okay, so I'm going to graph that. At pi halves, I'm at 1. At pi thirds, I was at 1.26. At pi 6, I was at 2. At 0 degrees, I was at 3. Sorry, this guy is not over here. 4. At negative pi 6, I'm at 4. At negative pi thirds, I'm at 4.7. And at negative pi halves, I'm at 5. So that's that part of the graph. Where's all the rest of it? Because it should be a lemicon. But we know about symmetry, don't we? It's going to be symmetrical. So therefore, just kind of put him over. Yes, sir.
So how do we call that graph symmetry?
Because I see the sign, I bet you would plug in the pi half ones and it's come out. If you'd like me to do that, I can. Okay. What's your point, though? Okay. So there's our graph. That looks like a lemicon, right?
That looks pretty hard.
Yeah. They have a cool name for it. All right. So, that's all right. So, I'm going to go ahead and prove symmetry here. R equals 3 minus the sine of theta. So I'm believing it's symmetrical about pi halves. Okay? So if you recall with the pi halves, that was r comma pi minus theta or negative r comma theta. Those were the two ways to do it. Okay? And as Ms. Spangler said, sometimes this one works and this one doesn't, and sometimes this one does and this one doesn't. But I'll show you either way. So let's go ahead and try the first guy. Okay? R, because I don't change my r, that's why r and r are the same. You with me? Equals 3 minus the sine of pi minus theta. Okay? So, what I need to do here is the sum and difference formula. If you'll recall, I'm gonna come over onto another one really quick.
Do you want to put like 2 in there?
Was there a 2 in there?
Yeah.
Oh, out in front, huh?
Yeah.
Okay, I got you. So it was 3 minus 2
Yeah.
sine of pi minus theta, right?
Mhm.
Equals r. All right, so I'm doing math on this one. I'm gonna work just with this right now. Okay, just with this. I'm gonna show you the sum and difference formula. I don't know if you guys remember. This is sine of pi, sine of theta, minus cosine of pi, cosine of theta. Okay? I think that's what it was. It's been a while. Can I see some of these terms real quick? And in the front. Oh, I did law. This is different. Oh, sorry. That's why I'm not expecting you to do it right now. I haven't done it for a while. This needs to be the cosine of theta minus cosine of pi sine of theta. Yes, sir.
I'm confused, so earlier we ended up, this kind of getting on the problem, so we just I'm confused.
I'm good.
Earlier, on the last problem, we replaced the r theta.
We'll do it
with
again.
r negative theta, so how do you know?
I'm gonna show you this one thing. Okay, so first off, let's come back to this other guy. Ah, where's he at? Right there. Okay, so coming back up here, we believe he is. We believe he's symmetrical about this axis. Right here. So notice we have r comma pi minus theta or negative r comma negative theta. I'll show you both. Because that's what we have symmetry about, right? Did I mess that up down here?
It's the line of pi now, right?
Pi half, yep. So, sorry if I messed it up. It was r comma pi half minus theta, which I'm doing right now. I could do negative r comma negative theta in just a second, okay? So, anyway, what's the sine of pi? 0, 0 times that, 0, right? Is everybody with me on that? So this guy's just 0. Cosine of theta, that's what theta. We don't know what he is, but we know the sine of pi is 0. And then negative, cosine of pi is negative 1 times the sine of theta. So that becomes 0 plus sine of theta, which is just sine of theta. So this thing right here is the exact same thing as that, which is just r equals 3 minus 2 sine of theta, and that was what originally we had, wasn't it? So therefore I just proved that it was symmetry with the pi halves. Okay? So now, you want me to do the other one as well? Is that what you're saying?
Sure.
Okay. This is where Miss Fainler said it might not come out, but I'm going to try it just to see. Okay? R equals 3 minus 2 sine of theta is what it was. And if you recall, it was negative r negative theta, correct? So this would be negative r equals 3 minus 2 sine of negative theta. If you recall, that negative does what? Comes out here, correct? So therefore you have negative r equals 3 plus 2 sine of theta. Now this is my justification, but I don't know if it's so true, to be honest. Once again, trying to be comfortable with this lesson myself, right? Haven't done it for a while. So r equals negative 3 minus 2 sine of theta. Okay, so let me ask you a question here. Can sine be negative again? Where does sine equal negative 1? At 3 pi halves, right? Okay, so or negative pi halves, whatever you want to say. So this is negative pi halves. And when I get that, it becomes, actually, where is sine equal 1? Sorry, I'm thinking about this as I'm teaching you. It's at pi halves. Sine of pi halves is 1, negative 3 minus 2, so our r would be negative 5, correct? And what was my theta? It was pi half, because that's what I plugged in to get that. So if I come back to this one, and hopefully I'm not trying to confuse you guys, so don't, just kind of, if you're getting confused, bear with me for a minute. Okay? But when I just graphed him, it was negative pi half. Where the hell? This is messing me the heck up. Okay. So, but notice it was at 5 negative pi halves. Now I have negative 5 comma pi halves. So where here's pi halves, here's negative 5 shoots me through, and I still get the same answer. So it's the same result. It's just a different way because now we're doing something different. But it's the same thing. Does that make sense? It doesn't look exactly the same. It might, and this is my feeling on this, and I might be wrong, but this part needs to be the same. And I'm thinking that this is the reasoning because when I have R, that's just going to flip me to the other side. I'm going to use another angle that when my R comes out negative is going to push me through to get there. Does that make sense what I'm going for?
Yeah.
And I think that's the reasoning why that happened. So as long as this guy right here is, I guess, the same as this one.
In the first word is like R pi minus.
Pi minus beta.
Yep.
Ethan.
Negative 2 sine theta is the same as upward.
Oh, was it?
That,
What did you say?
as long as the negative 2 sine theta stays the same.
It does. Okay. All right, really quick, I need to, we only have a few more minutes, so I need to just talk to you. You're okay? I can have a good. Okay, really quick. So this guy down here is a rose curve. Can you see how they have petals? Okay, let me show you how to do this one really fast. It's really simple. And this is the part that I need math help on, not just graphing, okay? Really quickly, if n, notice n is the number in front of theta. You guys all see that? Okay, if n's in front of theta and it's odd, you're going to have the same amount of what n is, petals. So in our case, our n is 3, so how many petals are we going to have? 3. So let's pretend this n was 4. That means it's even, right? So how many petals would you have? 8. And let me show you how to graph this really fast. What's the highest sine will ever be? 1. What's the lowest it'll ever be? And because our radius puts us basically on the same spot, because when you have a positive radius or a negative radius, it's still going to be on that radius of 1, right? Does that make sense what I'm saying? So, the highest cosine will be is also 1 or negative 1 times by 4. Everybody see that? So what I want you to do is symmetry. Okay, so first off, what kind of symmetry do you think this has? Cosine, so I believe it's about the polar axis. Guys, if it needs a little bit of time, I'm going to keep you and I will excuse you, okay? I just want to make sure this is the last part that's really kind of important. Okay? Now, it asks you, what value of theta gives me a maximum value of r? Well, our maximum value of r will be 4, because cosine is going to be 1, correct? The highest it'll ever be is 1. 1 times 4 gives us the highest value of 4. That makes sense, doesn't it? What's the lowest it'll ever be? Negative 4, but with a radius of negative 4, it's still on a radius of 4. Do you get what I'm saying by that? Because of pushing through when you have a negative radius. Well, let's go ahead and say that. So where does cosine of 3 theta equal plus or minus 1? Where does that happen? Well, where does cosine equal 1? At 0, right? And we could just say actually 2 pi n. Because 0 plus 2 pi n is just the same thing as 2 pi n, right?
Why
Is
can't
it-
we just say pi n?
It can't be pi n because 1, now give me 1 second. Now if I want plus or minus, that technically does work. Pi n. But I was just talking about just 0 in the first
Oh,
place. Because, or excuse me, 1. 1's only at 0, 2 pi, 4 pi, 6 pi, right? But now if I'm talking about negative 1, that happens at all every time it's just the odd pi's. But if I just do pi n, that covers both answers. Now guys, this equals not x, but it equals what? 3 theta, huh? Does that make sense? Okay. So, I'm going to still put this 2 pi n here. So I'm going to start with this and I'm going to start here because that's what made sense. Stick with me just for a minute, guys. I apologize. 2 pi third n. Okay? So at 0, if I plug the cosine of 0 in there, I get cosine of 0 is 1. 1 times 4 is 4. So at 0, 1, 2, 3, 4. Okay? When am I going to get back to the highest value of 4? 2 pi thirds. Give me another 2 pi thirds. Down here, 4 pi thirds. And what happens is, because of the petals, you can just kind of draw your petals at those increments. But once again, I'm not going to actually ask you to do this by hand with the graphing. That's going to be a calculator work, okay? But I will ask you, where does it give me that maximum value? So you need to say, oh, where does cosine give me my maximum values at? When it's 1, huh? So
1 times the coefficient.
Exactly. So therefore, you just say where it equals 1. And then notice because this was 3 theta, I have to divide it by 3. And then notice it's going to ask me, when does this equal 0? Well, it's asking where cosine equals 0. When does that happen? Pi halves n, basically. Right? But then we divide it by 3. It happens every pi 6. So when I'm at pi 6, I'm at 0. Does that make sense? My graph's not as pretty here, but it really isn't going to be on that pi 6. It's a little bit narrow. So on the pi 6, you'd be at 0. Does that kind of make sense? And that's why you'll have petals there. Are we okay with that? Really quickly down here, same kind of thing. A lemniscate is when this is squared. Just kind of plug them in as well, but look for those, okay? Your homework. I don't know which page, 10-8. You're doing 1 through 25 odd, 33, and I think 37, I want to say. Okay? Thank you. I will send an email right now if you are late to the next period. I'm going to give you 2 minutes to be late. Make sense?